awesome, people. How's it going? I can see so much going in the chat already. That is awesome. I'm so glad y'all are so excited about the stream. Okay. My laptop's doing a weird error right now. I'll fix that. So, okay. Awesome. How's it going? So, today's stream, of course, we have two streams back to back. So, the first stream is going to be a nice recap about electronics and all the basic stuff. Then we will write a little bit of Arduino code, which is fairly simple. All right. What I am trying to do is I'm trying to get one of the simulators up and running so that you all can connect to a database using a simulator. And if we can do that, it'll make our life much easier with the hardware part. Hi, Shubhankar! And yeah, it'll be fun. So today's stream will just cover electronics. If we should take around 35-40 minutes to do that. Then we'll write some quick Arduino code and connect a simulator to the Firebase database. If you're a new, don't worry, I'll walk you through every step of creating the Firebase database, getting the right credentials. I will be sharing my screen, so I am looking forward to y'all not misusing any of the keys or anything that I show on stream. Uh, of course, safety purposes, I'll be deleting everything right after. But what I will do is, as I show you, I'll be taking snapshots, and exactly those snapshots will go on the GitHub with the entire write up. All right. So it'll be very simple. At any given point, you can come back, and if you have questions, you can just directly create it in the GitHub repo, the issues, and I'll just answer on the go. Right. That's part one. The second part, we'll take a nice 20-25 minute break each way, and once we're back, we will create a React app. We can start creating a React app if we get time right now. I want to keep the streams limited to an hour and a half. That way, you all don't lose concentration either, and it's fun for everyone. And I can keep up a pace, right? Right. So, electronics and Arduino code right now. Not Arduino code exactly, Arduino IDE code. So we'll be using embedded C of Arduino IDE, but we'll be doing it on ESP32 by how we'll go understand as we go. And in part two, we will create a React app and we will just pull data from Firebase. And then we'll try and send data immediately that shows on Firebase and basically then send the data back. So we'll do a read and write from create React app onto a Firebase. And that's it. That is it. Once we're done with that, I'll create a nice template for everyone and eventually upload it onto GitHub by tomorrow, say. And yeah, for the next one, we'll just take the same code and we will see how sensor values and different values in UI can be, changed as per the problem we're trying to solve. Alright, so we'll be doing a nice design thinking session in the third session. But today is fairly simple, like I said, right? So depending on our pace and how it goes, we can get over early, we can stay on. My streams usually go on, so nothing unusual, right? I see there's a completely different discussion going on, which is great. I see a nice question. So I will be showing a ESP32, so I'll run the code on an actual controller. I am, however, trying to see if a simulator can handle Firebase code and Firebase connection. If it can, it will be fun because you all will be able to follow the entire thing very authentically, right? So I am just trying to do that. Give me 1 second. I'm going to just verify. If not, we'll write the code and we'll see what changes we'll need to make it run thoroughly. All right. So I ideally would have liked to use Technicat because I know a lot of people are way more comfortable with it. So it's okay though. Don't worry about it. I'm just going to try one last time before we start. So we'll start with making a Firebase project, alright? That way there'll be a little revision. So we'll first make a Firebase project. Then we'll go back, revise some basic electronics, circuits, microcontrollers, basically build our knowledge up to microcontrollers when it comes to like terms and stuff, like technical terms and stuff. And awesome. So you know how we start, right? So I will very quickly give my introduction. That's the only slide I'm ever going to use in this entire part series. So everything's going to be hands-on. Let me quickly pull up that slide. Hmm. Let's see. I have over 800 tabs open, so it's always very difficult for me to open the right slide at the right time. But I'll just open it from scratch for you all right quickly. And also, while we're doing it, right, at any given point, if you feel like you want me to repeat something or go over something, just quickly stop me. I will make a note of it, and I'll also add it to the GitHub repo when I'm adding the instructions. All right. Awesome! I found it. That's great. That's a lot. You already know quite a lot, right? So I'm just gonna go over some basic digital thing. We will use a little bit of scratch coding. But awesome. So share screen. That's it, folks. That's the only slide you're gonna see throughout the series, right? So if you're joining for the first time, hi everyone. I am Ritvy. I did a stream like less than an hour ago, and yeah. So we're going to be doing IoT. So I always take streams on IoT. I'm a hardware fanatic because I love playing around with hardware. I haven't been doing that much lately, so I'm a little rusty. But we'll catch up together. And yeah, I identify as a maker, so you all can see my background. Yeah, I love playing around with tools and materials. And I've been a coach at Major League Hacking for almost a year and a half now. So I do these streams fairly often. And I love interacting with hackers, and especially when you all turn up and ask questions and follow along. Remember, pace is not a problem. If we run over, I'll add another stream at the end of the week and we'll complete stuff, okay? So don't worry about it. We will, go at the pace you all want. Yes, I am from Cummins College, Pune, Vaishnavi. Are you from Cummins as well? I know like a very tiny percentage of Cummins College participated at MLH. So yeah, but cool. So y'all are here and let's get started. This is the only slide we're gonna see throughout the weekend. Alright. So I usually awesome. Did you pass out already, Vaishnavi, or are you still in college? Okay, so by the time Vaishnavi answers, folks, you want to open Wokwi and Tinkercad in case you all are going to want to, do a little bit of electronics with me before we get started. All right. So in case you all don't know, Tinkercad is a very nice simulation website where you can do like simple circuits very easily. All right, let's get started. Let me send you Tinkercad link. We'll make a very simple circuit just so that you all understand how the circuits work, what is VCC, what is ground, very simple stuff. And once we do that, we will look at a little bit of code on Tinkercad itself, so digital write, analog write. And once we understand the difference between digital write, analog write, digital read, analog read, uh, we'll move on to connecting to our database. It's going to be fun and simple. All right, so I'm waiting for you all to open Tinkercad. Let me know if y'all have it open, if y'all are opening, or you all have already done it and don't want to do it, in which case I'll quickly just run through it. All right. And I lost my tab again. No worries. Alright, is anyone following along? Is any if y'all are not following along, that's fine. I'll just do a quick run through in case anyone wants to watch the recording later. No one's following along? Take your time. So what I'm gonna do, okay, so in case you all miss out and you don't want me to repeat, but you do want a step, quickly go on YouTube while the live stream is running. You can go back and look at the thing. So in case you all are hesitant to ask questions, okay. Awesome. Shestronic is starting the computer. Vaishnavi has opened the Tinkercad, and so has Faraz and so, oh yeah, she's not on a radio station this time. Perfect. So yeah, if you all are following along, I'll do it nice and slowly and make sure you all are following along. Otherwise, I would have done a run through. So do not worry about the what we're covering. It's my job to make sure we do all of it, and we will. But so today's session is kind of important because it's the basics, right? And because we're going to build upon it. So take a time, follow along. I'll take you through some circuits we did earlier. If you all want, I'll send you links that you all can follow along. And of course, the last month's tunes are obviously up on YouTube that you all can watch. Right? Awesome. Let me start by sharing my screen. Oh, before we forget, do register and check in. Wrong link. A little slow today for me, but catch up. There you go. Do register and check in. You all are working hard. You all are here, paying so much attention. So make sure that you all get your community points from them. Alright, awesome. So let's get started. Share screen. Just share the window. Should I share the window? Let me share the window. I'm gonna pull it out and then share the window. Share screen. Share window. There we go. Alright, folks. So how do you want to go about it? I initially thought we can start with setting up a Firebase project, and then we go do Tinkercad, then we come back and understand what we did from Firebase and then add it, right? Do you all want to do that, or would you all like to go in the sequence where we do electronics and then we shift platforms all together? Take your time. I'll, for the time being, continue with Tinkercad. Alright, and if you all want to do Firebase first, or this gets too heavy, you'll take a short break. Firebase setting up is very easy. Alright, so it should be easy. Y'all are smart kids. I'm not worried at all if y'all not following along. But alright, so these are some things that we did earlier. So from where did we start? We started around here and we went on till here. Right, so let's start with this one. Let's see if where do I open it? Look at this. Cool. So what we did here was we differentiated between looks like GTG. Nice. So what we did here while tokens is we tried to classify active components and passive components. All right. So what are active components? What are passive components? So very, very quickly, right? If you all have examples, do let me know. I'm happy to explain because we did this activity where we went around the house and we found active and passive components, right? So active components are components that have the ability to, somehow add to the power in the circuit. Now, this is not a very accurate definition because as you go and we start classifying components, you realize it can be a tad bit more complicated, right? But this is the basic overview of what we did, right? So if you see, these are active components. Battery is the most obvious example of an active component because it's supplying power. It's supplying the entire power, right? All these components on the left, right? They're all passive components. Why? Because they're either using up power or they're basically, components that are incapable of doing anything themselves until and unless given something from outside, right? So you see the classification that's been done. If you all have any questions, let me know. Otherwise, I'll move on. Right. So active components, passive components. So let's just quickly go over examples. Right. Can if just one of you does that, give me examples of active components and give me examples of passive components. Like very quickly. This is a very quick revision that we're doing. So active components, battery, right? So everyone knows it's a battery, or your wall sockets. They're all active components. Give me one quick example of a LED. Just an LED is fine, right? So passive component, great. LED is a passive component. What about a resistor? So you want the link to this Tinkercad, Faraz? I'm not sure if I can share it. Let me see. Go send to. Do you want a picture of this design? I'm not sure. I think I can add collaborators. Hmm. Okay, copy. Alright, there you go. So I'm sending you this link. There you go. Yeah, I know you should be able to share it now. I'm not sure how if this link lets you edit it or not. It does let you edit it, and I'm a little worried because I don't want you all to edit this. It did take a while, so I'm just gonna go back and create a copy of it. Hmm. Duplicate. Cool. So one is your copy. If you all make changes to that, that's fine. This won't change because this has happened with me before. Every time I share something publicly, especially if something that we make changes, someone just goes CTRLA delete, like collaboration boards, Word documents. This happened when we did Fake Artist Goes to New York. Okay, so I was like, oh, so yeah, I'm a little paranoid about sharing stuff publicly now. Exactly, that's a great way to look at it. See, that's what I mean. So it stores energy. So it's passive. Awesome. See, that's the thing. None of the active hackers do it, which is what I know. And I won't be surprised if one of the times I have done it myself. But that's okay. So, always good to be safe. And it's not your job, it's my job to make sure that the content remains safe. Alright? Awesome. So we now know the difference between active components and passive components, hopefully. Now, we did an entire stream on this in January. So if you all are confused, if you all want to go have a look, go back to January streams, search for electronics part one. You've seen people have given amazing analogies. People have gone around the house and posted pictures of active and passive components in their house. So go ahead, do that. All right. And if you all have any questions, however, right now, feel free to ask them. Right. If you want to go back, you're going to come back later anyway. Don't worry about it. All right. Perfect. So that was the first thing that we did. Right. So once we understand what are active and passive components. The next part is building with these components, right? We're basically building, these are our building blocks, right? So the next thing we do is we build a circuit, right? So this is not the circuit I want, this is the circuit that I want. Alright, I'm going to click on this, I'm going to tinker this. I'm actually going to go behind first and duplicate it. Let's do that so that you all can get links as we go. So you all don't have to create this from scratch. So copy link. Oh, this is what I wanted. Privacy, share link, license. Okay, I can't change the editing, so I'll have to create a copy anyway. So let me do that. Duplicate. And I'll share this with you all. Right, so anyway. So once you learn active and passive components, the next thing you want to learn is how are they sharing the power, right? So let's say let's say I have an active component and I use it with a passive component. What will happen if I add multiple passive components? I just realized I'm not sharing my screen. I don't know why I stopped sharing my screen. I was showing you all what was happening. Okay, this is what I want you all to see. Alright, so this is what I wanted to see. So once you have active components and passive components, this is the link that I've already shared in the chat, right? So how do you build upon it, right? So if you have a battery and you have components, what happens if you want all of them to light up with a certain battery source, or if you want to limit it, you want to limit the brightness of it, how do you do it? So you see there are two circuits we have here, right? So one, we have LEDs connected in series, right, and one in parallel. So what's the difference between parallel and series? Very simple, right? So if you all look at the diagram here, this is the anode and the cathode, right? So in my series connection, always my positive goes to negative. This is actually the other way around. So the positive will go to the positive over here, and then the negative goes to positive, the negative goes to positive, the negative goes to the negative, right? So that is how I make a series circuit. Remember, when your components are directly connected to the active component, the positive and positive match. But if they're connected in series, the components, not the active source, positive goes to negative, negative goes to positive, positive goes to negative. So it's like holding hands, right? So that's how series works. And then there's parallel circuits. What's happening in parallel circuits is all the positives are connected to the positive, all the negatives are connected to the negative. Simple. Why? Why bother with the difference? Simple. So the difference is, the only difference between both of them is the current and the voltage. In parallel, right, in parallel circuit, which is my left side circuit, the voltage remains constant, right? So no matter how many LEDs I add here, all of them will get this entire voltage of 3 volts. In series, the current remains the same, right? So the current will be same across the entire circuit, but the voltage will keep dropping, right? I don't know if you all did numericals in ninth and 10th, right? We did voltage drop numericals where we calculated the resistance dropping. How did we do it? We knew the current in the circuit and we knew the voltage. So we just did, voltage, and then we did a current into resistance to get the voltage drop, right? So if you start with 3 volts and the resistance is, let's say, 2 ohms, and you have a current of 3 amps, right? So 3 into 2, 6 volts. So 6 volts will drop. Now that's not possible, right? So your voltage will have to be at least 12 volts. But you get the point, right? So in the series, the voltage drops, but the current remains constant. Here, when I say the voltage is constant across the batteries, remember the current is not, right? The current is different. Current is not constant. Make sense? Everyone on the same page, right? So that's a simple thing. So what we did after this was, once we made the circuits, which I completely think that you all should make it yourselves if you all haven't done this before. We actually put digital multimeters, not digital multimeters, like multimeters, and we actually calculated the voltage and current. So you all should totally do that. All right? Everyone on the same page? Is anyone following along? Am I going too fast? I can slow down if you all want to follow along. Am I going too fast? Yes, I know, right, Alvin? I love the names as well. This and GitHub code spaces, they have very weird names. I'm going to take it the yes as you all are following along, not that I'm too fast. If I'm too fast, tell me, we can slow down. Alright? Alright. Awesome. Great. Alright, so let's move on to actually using controllers, right? Okay. So remember, when we do electronics, right, it's all about voltages and currents, all right? So any signal, anything that comes to you in terms of sensor values, right, they're all voltages and currents, right? Forget even currents, they're almost always, especially your sensor values, right, they're voltages, right? So what do your microcontrollers do, right? Your sophisticated microcontrollers, all they're doing is playing around with voltage, right? They're communicating with voltages amongst themselves, and they are reading and writing voltages, right? So remember that at any given point, when I say digital signal, analog signal, when anyone says signal, you should be able to imagine the voltage curve in your head, right? How do you do that? It's very simple, right? I've covered this multiple times and very simple. Let's go back to our Tinkercad and let me open a random. This seems like an incredibly difficult project. I want to start with something simple. Let's start with this, right? Or let's just start a new project. Never mind. So we'll just go to new circuit. Alright, so we're going to do a very simple thing, right? So I'm going to take an Uno. You can take anything. The concept is going to be the same, right? So you see all these pins here. This is your microcontroller, by the way, right? So the black part, the ugly-ish part in the controller, that's your actual controller, all right? This is your evaluation kit, all right? I have, again, if you all have attended any of my streams before, you'll probably know this by heart by now, right? So all these controllers that you get, right? Arduino, you know what? Let's just take one quick step back and quickly discuss the difference between controllers and processors. If you all have attended my streams before, you all know the answer. Tell me the one way you all can tell that this is a microcontroller and this is not a processor. Come on, quickly. It's a very simple answer. It has something to do with the OS. Come on, I'm counting on you all. I'm always surprised. A couple of the hackers, they've heard this same thing so many times and they're always here. Okay, no worries. If you're from CSE, that's not a problem. So here's how to know the difference between a controller and a processor. Alright. So a controller, okay. So let's start with examples, right? Where do you see processors? Your laptops, yeah. A Raspberry Pi, technically, not technically, it's definitely a processor, right? What else? Computers, laptops, those are examples of processors. What about controllers? Washing machines, microwaves, TVs. So what's the basic difference between both of the functionalities, the basic functionalities of these chips? One has to be dynamic, right? It uses a GPOS, a general purpose. I like the attempt Shellstronic IC chip size. That's a very good observation. That's a great observation. But no, remember. So how can you, if you're ever confused about whether it's what kind of OS it is, right? Just think about what it does, right? If it uses a GPOS, a general purpose operating system, which means that, let's say, like on my laptop, right, I take my mouse, it has no clue what I'm going to be doing next, right? It can't possibly predict. So I can just take my mouse, click on a tab, I can go open a new window, I can do whatever, right? It has to be ready to be able to allocate memory, to be able to, do that task. A microcontroller, however, cannot do that. A microcontroller has timed stuff, right? So if, for example, take a washing machine, right? There are certain tasks that have to be done in a certain time. So, and it only runs that one program, right? So let's say, rinse the clothes for 5 minutes. It's only going to rinse that for 5 minutes, right? The next time it's going to do the drying soaks, cycle. So it's going to run that for 20 minutes or whatever, right? So it has a time limit and it is running that one single program over and over again, right? This is called an RTOS, a real-time operating system, all right? So if you are ever confused, if you look at a device, right? We did this activity. We look at a device and we tell whether it's a, processor-based system or a controller-based system. And there's only one way to, a very good way to differentiate is what OS is it running. And how do you know that? By seeing the pattern. If it has one program that is just, like, of course, these days everything is sophisticated, right? The washing machine connects to the Wi-Fi. It has, it has sensors to tell you and give you more errors. But in the end, it's running that one program, right? Which is, programmed to click two buttons. If you went ahead and, you can't download new softwares onto it, right? You can't just ask it to do whatever. It has that one program that has multiple functionalities. It's a big program, but it's just one code running. A GPOS, however, is a system, right? It's a system and you can download softwares, you can do whatever, give it the hardware constraints, right? Does that make sense? See, this was true, but I'm trying to help, and it still holds true in a lot of senses, but I'm trying to help you differentiate in today's world where there's a very marginal difference between the tasks that, processors and controllers are performing. Right, and if you ever look at a data sheet, right, let's say if I open this controller, right, the Arduino controller that's in front of me, there'll be two data sheets that I'll find. One is the Arduino Uno data sheet, and one is this chips data sheet. So the chip is actually the microcontroller. So when I go and look at the chips data sheet, it will still say the processor, right? So in the end, it's the processing chip, right? But how do you know it's a microcontroller chip? Because it can only run one program. When you program it, it's going to run that one program over and over again. Does that make sense for us? No, no. So that's the same. That's true for everything, right, Alvin? So let's say my Atmega chip is capable of doing something, so and so things. I don't always have to use all of it, right? I mean, the Arduino also only takes out some of its functionalities. There's so much more you can do with it. You just have to build your own circuit, right? In the end, it's just the data sheet. So, and when you phrase it like that, that's true for processors also. If it's anything, if it's like way more true for processors, right? Because you're literally doing anything with it. There's no specific. No two people use the laptop the same way. So, did that make sense, everyone? Yeah. So, quick why I went back was because I was about to say that this is a microcontroller, and I realized I never explained what was a microcontroller. But again, people who have been attending my streams probably know all the definitions I have, right? So awesome. Great job, folks. Right. So this is our controller, right? This is our actual controller, the black chip here, and this is our evaluation kit. All right. So any chip that comes out, right? Why would you buy that chip? Because you have to design circuits, right? So if you look on the board, you see a lot of components, and you can classify them as, active or passive components. So you can see here there's a voltage regulator. Either this or this is a voltage regulator, right? What does a voltage regulator do? So you can see 3 volts and 5 volts on the controller, right? So there's a ground, there is a ground, 5 volts, 3 volts. How is it being able to give so many voltages when you're giving it one power source? It has voltage regulators that are, regulating the voltage and giving certain voltages on those pins, right? Awesome. So you can see a lot of components. There are LEDs, passive components. There is the oscillator, which is giving you time. Remember, a very important component in a microcontroller you'll almost always have to add is an oscillator. Because if you're telling your controller that, okay, wait 5 minutes, how is it counting the 5 minutes? You'll always need an RTC, right? A real-time clock. So yeah, these are some components, right? So you can now see that they have some weird marks on them, right? So 0, 1, there's a random tilde wave here. Then they've randomly started writing A in front of pins. It says digital and it also says PWM. So many new words, right? Okay, I see a question. What would you want most? Exactly, Alvin. Precisely why I ask you all to differentiate with the kind of code you're writing for them, right? So in a controller, remember, regardless of how sophisticated the controller is, no matter how many displays you're giving it, finally, if you're putting in one code that is capable of doing a certain amount of tasks, it's a controller. Makes sense? In a processor, like for example, your laptops, you can just keep expanding, right? And you can keep adding RAM to the laptop will have specifications, not the processor itself, right? So you can keep adding RAM to it, you can keep adding SSDs to it. Doesn't matter, right? The OS program won't change. A controller does not, however, work that way. Yes, but it's finally one program, right? It's a one program that's running. Oh, it has a lot of sophisticated code inside it, but it's finally one program. Am I making sense? Great points. Which is why I always ask you to differentiate based on the OS and not the actual, features of the chip. No, you still don't get it. So even if you write a very sophisticated scheduler and a priority, you add threads and whatnot. When you do a control upload, once you upload it, it's that one code running over and over again. You can't just go and it won't change the code if you click a button here and there, and you can't dynamically change what's running. However, in OS you can't. You in a GPU OS you can. Make sense? Kind of, sort of. You get back to me whenever you're ready. Anyway, so let's go back to our Arduino here. Alright, so now we're going to be doing awesome. Yeah, it made sense. Good. If you still have questions, feel free to pester me. That's what I'm here for, right? Right? Alright, perfect. So now what we'll do is we'll quickly connect a few components and understand how their signal is different, right? So what I usually do is I usually share a jam board and show you how the signal varies for different components and how you're reading it, right? So let me stop sharing screen. Let me share again and let me share the window. Excuse me. Awesome. Right, so this is my entire window. Hopefully, can you see my window? Yes, you can. Perfect. So I'm gonna go here and I'm gonna open a Jamboard very quickly. Right. So, Jamboard. Don't look at my other very bad sketches. It's mostly always signals, me explaining signals. Oh my god, there's the new button. Yes. Alright, so we'll come back to this in just one bit. Alright. So I'm gonna do here something. I'm gonna see if I can share this with you. But cool. Are there any other questions? No? Awesome. Great. So let's move on. Give me 1 second, folks. Alright, folks. Let's continue. So we're gonna go back to our Arduino and we're gonna start attaching our components. Alright. So we're going to attach a few components and understand the differences. First, we're going to attach an LED because, right, I'm not connecting it just yet. All right, so LED, then I'll add a potentiometer. I'll explain why. All right, I do not need a battery because I have a USB connection here. So that's where it's going to get its power from. And let's see, is there anything else I want to attach? We can attach a servo. Let's attach a DC motor. I think we need a motor controller for that. So I'm going to remove this first for the sake of avoiding complexity. I think a potentiometer and an LED is a good enough thing right now. I do want to show you all PWM. I'll do it with I'll do it with the LED. Cool. Awesome. Sounds good. So let's start by connecting our LED. Alright. So okay. Where will I connect the LED? Any guesses? You see that there are 3 pins, right? There's PWM pin, the digital pin, and analog in. Where do you think I connect my LEDs? Come on, folks. I know a lot of y'all have already pinned to this before. Where will I connect it? Digital. Awesome. Great answer. Why? Why not analog? Why? 227. All right. Why not analog? Why not PWM? You guess it will work. Good guess. Right, so I usually do this intuition game with you all in the beginning of the session, which I'm avoiding these days because I've realized it takes up a lot of time. So we'll do it in the next session onwards when we, build the entire project. But Awesome. Alvin has given the perfect answer. Right. So now let's go back and study our signals, right? I am just waiting for my thing to sync. And once it does, I'll be able to draw it for you. So let's see if it has uh, mm, signals. Just a much. Awesome. I think I should be able to sync now. Perfect. So great. Anyone, any questions at this point? We can continue, right? I know Rati and a couple of other Farhas were following, but I don't see them answering anymore. So I'm a little concerned. But that's okay. So let's go back to our Jamboard and understand signals, right? What did I tell you all? That everything we do is a signal, right? So let me get this. Oh, can you see my drawing? Awesome. There you go. You can see my drawing, right? So everything is a signal, right? So based on what I'm sending, right? So we have voltages, right? That's basically what all I'm reading and writing, right? Right. So voltage, right? This is my digital, and this is my analog. Can you all see the changes happening to the board? So it's that. Okay, there we go. Right? So digital and analog, right? So what's the difference between digital and analog? Digital wave basically gives you a square wave, right? So let's say this is your plus 3, this is your minus 3. But does it give us minus? No, right? So your lower becomes 0, right? So there we go. And let's say your analog, right? What's an analog signal? It's basically a sine wave, right? Again, this is usually negative in your graphs, but we do not have negative. So this won't be minus 1 or minus b, right? This will be 0. So when anyone says minus VCC or, uh, the low part of the VCC, it's basically 0, right? Because you do not have negative voltages, all right? So, great. All right, so now you know the difference between analog and digital. Now let's look at the digital a little more, properly. So, okay, now I know this is my 0, this is my 3. Is my wave actually ever like this? No, right? It's just this. This is basically my digital voltage. This ideally does not exist. Correct? Digital is discrete. Exactly. It's discrete. But what do you mean by discrete? Remember, your microcontroller does not understand vocabulary, right? It does not understand English. You can't tell it, read discrete signals. You have to talk to it in voltages, right? So, yeah, exactly. Ideally is the keyword, right? So, ideally is always the keyword in electronics, right? That's how you understand behavior. So, let's go back, right? So, this is your digital wave, right? So, it's going to get voltages. So, how does it know or know signals? It's reading voltages. So, like I said, we have a voltage regulator that give us a 3 volt and a 5 volt, right? So, let's just assume 3 volts. It's actually 3.3 volts, right? But for the sake of calculation and everything, we'll just assume 3 volts. Okay? Alright. So what is a high and a low? So you know that the LED will turn on when you give it 1, right? Which is why you all told me connected to digital pins. But what does it understand when I say 1? That means 3 volts, right? When I give it 3 volts, it's going to understand 1. And when I give it 0 volts, it should understand 0, right? So ideally, if I take an LED, right? Let's say this is parts. I really need to learn how to draw an LED, right? LED. There you go. Alright. So this is the positive and the negative, right? So if I have a battery and I give it plus here and minus here, it's going to glow, right? That means I've given it the entire 3 volt of power. So it needs that power. So ideally, when you are connecting, right, over here, when you are connecting it to this pin and you're giving it a high, you're basically telling that Give it the entire voltage. Give it the entire 3 volts, right? What do you say when you want to give it? Nothing. You disconnect it, right? So basically, you're giving it 0 volt. As soon as you give it, disconnect this, the glow goes away, right? That means you're giving it 0. So when you go here and you tell your circuit, okay, turn off the LED, what you're saying is disconnect, right? Basically, stop giving it voltage. That's all you're saying, right? That's exactly what your digital is doing. But remember, your microcontroller does not know that, right? It does not understand what's discrete. It does not understand what's a square wave, right? All it what an LED. No, all it understands is voltages. So instead of looking or giving your LED a high and a low, what a microcontroller does, right? Ideally, is it divides it by two, right? Remember, I've been drawing this line continuously, right? If really 0 is my point, I could have drawn it like this. But remember, this half is very important. Your halfway line, right? You do not have a negative. Instead, negative is 0, but you still have that half point, which is very important. This is your digital, you can say, boundary, right? So this is your digital boundary. What's happening here is anything above it is considered positive or digital 1 or on. Anything below this, right, is considered negative or 0 or off. Make sense, everyone? Yeah, makes sense? Alright, so now we understand how digital works. What about analog? Hmm? So how does analog work? So now again, we have a sine wave, right? So let's draw sine wave. Remember, this is not negative. This is 0. And this is your 3 volts. So what's happening here? Hmm? Steps, kind of short. Let's take them as steps, right? Now imagine I connect my LED, right? I don't know what's happened. Now imagine if I connect my LED, I change the thing. Okay, connect my LED to a analog signal, right? So let's say I take my battery, right? Positive, 3 volts, positive, negative, alright, and I connect it to a regulator, right? So now this regulator is continuously giving analog values, right? So 0, no, 0, 1, 0, 1. Alright? So what would happen if I connect my LED? So this is the positive end and the negative end goes to the LED. Negative. I really need to practice drawing an LED. Okay, so this is how we connect it, right? So what's going to happen now? You're giving it an analog signal. At half point, you know it's either going to be on or off. Fair? Fair? So any time that it goes beyond half, ideally it should stay on and anything below, it should stay off. But does that happen? It doesn't, right? It never happens like that. There's something called brightness. You have your regulators. That's exactly what's happening. You're basically giving it an analog value, an analog voltage. Remember, everything on this scale is not just a number, it's actually voltage, it's actual power that you're giving, right? So, based on the power, the brightness of the LED matters, right? Make sense? Jati, Faraz, Alvin, Shelstronic. Same page, everyone? If there's anyone else following along, let me know. I'm happy to make sure that you all are there as well. Like, check up on you. Awesome, right? So now I'm just gonna go ahead and open a new page, right? So let's go ahead, open a new page. All right, great. Okay, so now we have analog pins. We have digital pins. All right. Here's what we're going to do next. You all are going to tell me components that I can connect to both analog pins and digital pins, but not, and then tell me components that I can't connect to both, right? As in, it'll be useless. And remember, we're only reading these components, all right, or writing to them. So let's say LED, we're writing, right? So let's talk about writing first, right? So LEDs, right? I can connect to both the things, right? So LED, awesome, right? So LED works for both. What else? What all other components can you connect to both? That will work, because even if you give them analog voltage, they'll be able to do something, right? Yeah, that's what I mean, Alvin. Which one will work? For example, LED will work with both, right? You can connect, you're right, you can connect everything to everything, but not everything will work. I'm asking the components which will work with both, and then we'll discuss which components won't. So, motors, that's a great example, right? So, motors are similar to LEDs. So, motors, cool, great. What will happen to motors though if you connect it to digital pins? It will run on its highest speed and the lowest speed. When you connect it to analog pins, you can control the speed of the motors. All right, perfect. No, it doesn't. So now let's go back to our Arduino and look at this thing called PWM, right? What do they mean by PWM? It does look good as a design, right? Let's give them that. But what is it essentially doing? Or so there's something called ADC and DAC, that is analog to digital and digital to analog. What's the difference between the two? Right? So an ADC basically converts your analog signals to your digital signals. Why bother? Why do you want to do that? Uh, let's say that we will look into it, right? And then there's DAC. So your digital signals into your analog components. Basically, if let's say I have a temperature sensor, right? For a temperature sensor, remember it's going to give me analog values, right? And if I want to read them digitally or read them in a value that I can map, I'll need an analog to digital converter. It's not converting into zero, not it's not converting a continuous wave into 0 to 1. Okay, always remember that ADC will not do that. ADC will make that sine wave readable to the controller. All right, and the DAC does the other way around. Let's say you want, so if you want to give out, let's say you want to write a certain number to a sensor, or say to the LED, right? Let's say if you want to give the half of brightness to the LED, right? You will want to give that number, right? So let's say you want to give half of the voltage, so 3.3 half. You want to give 1.65 volts exactly. Arduino's pin. You can't do that because an Arduino does not have a DAC, right? In place of that, what you do is you give a PWM. Let's have a look at what's PWM, right? So let's go. Okay, all right. So let's look at PWM, right? So let's go to 3, right? So let's look at PWM, right? So what is PWM? Have you seen Ant-Man and the phasing, Ant-Man and the Wasp, where the phasing happens? It's something similar to that, right? You're basically changing the state so fast as to create a new state. Makes sense? Little bit. So basically what you're trying to do is, so if you want to show that the brightness of the LED is 50%, right? So you're going to turn it on and off so quickly that it looks like it's turned on for half the brightness. It's like a flickering effect, right? So in the Ant-Man and the Wasp, I don't know if it's a good reference if you are a Marvel fans or not, but that she's spacing, right? She's changing states so fast that she's being able to stay in multiple states. Something similar, right? So let's have a look. So let's say this is my LED, right? And I want it to stay on, like I want it to be at 75% brightness, right? What I'm going to do is I'm going to take a time period, right? And I'm going to keep it on for 75% of that time period. and turn it off for the rest of the 25%, then turn it back on for 75% and turn it back off for 25%. So this is 75% and 25%. So this is my time period. Now usually let's say 1 second. 1 second is too much, but still you get the point. Right? So what we're basically doing is we're toggling it on and off so fast that it looks like the brightness is less or more. Make sense, folks? Makes sense? Even if it makes sense a little bit, it's okay. Because the reason why I'm covering all of this today is because when we start writing our code and we're sending sensor data, what data type you want to use kind of will depend on this. Not much, I mean, but still, knowing the basics never hurts, right? Did I answer your question, Alvin? So only the so turning it on and off also so quickly requires a certain circuit, right? So if you go back and look at the Arduino, these pins, the ones with the tilde on it, can do that, right? We can do an analog write. What will happen if I do an analog write on a digital pin? The logic remains the same. It's going to split the voltage by 2, and if it's over it, it's going to treat it as a digital high, or if it's lower it, it's going to treat it as a digital low. College is not that far away. You'll be able to use it soon enough. You actually have to do such experiments in college once you get there. So yeah, of course, they're digital pins. They're essentially first digital pins and then they are PWM. Remember, PWM is an add-on characteristics. If something can do PWM, that is maintain a high and a low, it can obviously do a high and a low alone. Make sense? Awesome. That is it for the basics, folks. I would want you all to connect this LED, right? Connect it. So remember the negative always goes to the ground, all right? And as a practice, we always turn the negative to black, okay? And the positive to red. If you have multiple things, the signal color can be of your choice. Your voltage and ground, right? Always be red and black. It's a very good practice to have. All right. Next, what we're gonna do is you can try out the code here, right? So I can start simulation, and I can go here, write the code. I prefer text code, but you all are welcome to use the blocks, right? So I'm gonna go ahead. I don't know. So this is doing a digital write on and off. That is fine. I should probably change. Okay, so it's doing it for the LED built-in, so I'm just gonna change it to 7 because I've connected to the pin number 7. 7, 7, 7. Start. There you go. So now I can show you PWM real time, right? So if I reduce the time here, right? Let's say I make it let's say I take 1000 as my entire thing. So I keep it on for 750. Oh, acceleration 750. And I turn it off for 250. I reduce the number if it's too slow. Mm. I'm not sure what I did wrong. It should be able to take 225, I'm not sure. Anyway, you get the point. So now this will stay on for 750 milliseconds, and 250 milliseconds will turn off, and it will basically generate a PWM. It's not Scratch, it's Tinkercad, Alvin, and it has the block code facility too. So alright, so folks on the same page, Farhaz, Ratis, Shellstronic, if you all are following along or want me to do a circuit very quickly, I'm happy to do that for you all. Otherwise, we can move on to the Firebase setup. We'll do the Firebase setup. We'll take a quick break and then we'll connect our Arduino code to Firebase. I'm gonna wait for you all to reply for another 5 seconds. Perfect, you did this. Awesome, Farah. So let's move on to our Firebase setup then. Yeah, we'll quickly set up Firebase and we will come back, and depending on how we want to go about it, we can either first do the Create React app, set up the Create React app, set up read and write functions, uh, and then we'll do the Arduino code because we just looked at some electronics. If you all want a break from it, we can do that. And yeah, today we'll finish the connection of sensors to Firebase, Firebase to React, and if you all want to eventually get like an ESP32, I'll be using an ESP32. You can also get an ESP8266. I do recommend getting one of them for sure if you want to follow along because it's very cool and it's very easy. Um, See, that's the thing. They don't need to be no, but it could be that this Tinkercad might need it to be of a certain multiple. We'll have to check. I'll check. Don't worry. I'll reload and try again, but it's okay, right? So let's move on to our Firebase setup very quickly. So I'm going to take a quick poll. How many of y'all have never used Firebase? Is there anyone who's never used Firebase? You've never used Firebase, have you? That's awesome. It'll be fun. I promise you. Firebase is fun to use. It's okay. It's fun. It's a lot of fun. Hi, Wombo Combo. Welcome back. Never? Well, I'll be using very simple. It depends on. Okay, you're welcome back. It depends on what I'm doing. Fair enough. Uh, so I'll be using the RTDB and Firestore. I'll be connecting my React to the Firestore, and sure, I will go ahead. So even Shellstronic has never used Firebase, which is awesome. Firebase is fun. You all will love it. It makes your hackathon, your hacker experience so much easier. So folks, if you all have any questions, let's take a 5-minute breather, right? And then we'll start with our Firebase setup. So first things first, right? I want you to very quickly go open Firebase if you all don't want to take a breather, right? So Firebase, let's search. We'll go here, right? I had a half a mind to like set up like a from scratch account so that you all can access the same project, but either way it ends up becoming fairly dangerous, especially because I end up getting charged. So we can do it in closed groups. If anyone wants to do like a collaborated Firebase project, let me know. We can do it one-on-one, but I don't want to end up giving links to people. Yeah. You wouldn't. Very simple, right? You have buttons, right? You have timer interrupts and you have interrupts in general, right? So you can have a button interrupt, a hardware interrupt, and you can switch over the code block that's running using what Wi-Fi? I don't get it. See, the whole point you create an access point first is because you're not storing the Wi-Fi and the credentials in the flash. Make sense? Or do you want to create an access point with her HTML page, which is fairly simple? Alright, so anyway, till the time Alvin asked the question, you all can go to Firebase, login, right? Login and come to the dashboard where you can see add a project, right? And once you're here, you all can take a 5-minute breather. It is 3:15 on the clock. So I'm gonna quickly pause the stream for 5 minutes and then we'll restart. And if you all have any questions until then regarding what we just did about signals and stuff, go ahead, ask them. Trust me, I've given you a very, very overview. I usually take an entire 2-hour stream on this. So don't worry if you kind of got it. It's the terms that matter. If you recognize them even, feel free to ask me again. I'll take you back and explain what we did. All right? Yeah, that you totally can do. The only problem with most times that why you can't do it is you not having enough space in the controller. Alright, otherwise it's very much possible. So how it would work is your access point would eventually, the same page would take you to the controls and control the or send out the code that you want to send over the controller you've connected. Because remember your access point finally is oh, you already did it. I don't understand your question still. Oh, okay. I kind of get your question now. Kind of. But explain it to me again later. I don't know. I still don't understand why you had to refresh it. I mean, you can just it like as soon as someone access uses the access point, it should ideally just directly take them to the next experience part of the experience, right? Hmm. Hmm. We'll look into this. Can you send me the code link? I'll have a look at what you did and see if I did it in a different way. Hi, Mind Blocks. Welcome to the stream. We're just taking a 5 minute breather. And yeah, we'll continue with setting up our. Alright, folks, let's take a quick. I kind of figured this was it. I did. But yeah, okay, send it to me. We'll figure it out. Awesome, folks. I'm gonna quickly go and get some more water for me. And yeah, you all can take a quick breather and then we'll come back and continue setting up a Firebase project depending on what you all want. So decide until then, do you want to set up the React app first or the controller in first? We can we can go about it. Alright? So let me quickly put this on pause. All right, folks, I am back. How's it going? Are we all back, or do we need another minute? Hi, usually. Hi. Welcome to the stream. Hello, hello. I'm glad you all are all here. Let's go back to our Firebase. I hope you all have created accounts if you all are doing it for the first time. I mean, accounts, as I'm sure you all have Google accounts, you all just need to log into uh, the console. Hi, Gaurav. Welcome to the stream. Uh, you know what? Alvin, go ahead. Go ahead and send it on Discord and have a look. Hey, Ansha. Welcome back. Alright, so you all are well in time. I'm going to start with Firebase. Did you all decide, do you want to do the Create React app first or the Arduino code? So I have great news for you all. The simulator code actually worked. While that's what I just wanted to confirm that the simulator code worked before I, of course, thought you weren't wasted time. So it worked, and it's sending data to Firebase, which means you all are further in on the simulator. We'll be using a different simulator though. All right, it's very simple. I'll explain the code first, and yeah, you all can just probably copy the template. I'm not that worried about you all not knowing the code. So we do a couple of writing exercises like analog write, digital write, mapping. Once we're through with that, I'll send you the template. You all are smart enough. I do not know, Alvin. The thing is, you need so the simulator, right? And I'm using a very heavy, not very heavy, but like a Firebase library. And I wasn't sure if it would work. And I was trying an example. So here's how I go about anything anyway, right? I'll pick up a library, I'll read the library, but then I'll use the examples first to understand the behavior before writing my own code, which is a very good practice to do. So it wasn't, I guess it was my Wi-Fi or something, I'm not sure. But it works. So it does work. We just have to figure out its behavior or if it's not consistent and things like that. Alright. So the shorter is Firebase and Create React app because we're basically doing nothing. And I'm sure all of you all here are much better web developers than I am. I'm not a web developer. I'm a non-existent web developer, but I'm happy to learn. So here's what I actually had a plan. If you all are actually interested in, doing the UI and stuff, you all can actually make some pretty UIs and I can just use them. So you can come on stream, explain what you did, and we'll just give it out as a template and everyone can use the same UI. If not, I'll of course work on some basic CSS and we can start with that. All right. So great. Questions. So let's start with first. Let's. It is. I don't know Wombo Combo. I mean, I feel like people who like. I'll leave the dark side. Wombo Combo is one of he was one of the mentors really when I first took the electronics streams. He really helped other people. So if you all have questions and I'm not answering them well, I think Wombo Combo would be able to answer it much better. Awesome. So let's get started. We've said that enough time. So I'm going to quickly create a Firebase project. Let's create the Firebase project. It's very simple. You literally need to click through buttons, right? I'm going to do, you all can see these are my previous hackathon names. GHW, March. We'll go for live demo, right? Fairly simple, fairly unique. Continue, default account. All right, I think I went too fast, folks. Is anyone following along? Do you all want me to slow down? It's simple. You just need to keep clicking buttons as they come. If not, I'll quickly create another project and show you how to go about it. Anyone following along? Well, it's creating my project. It's going to take a minute. So if you all want me to show you all the whole step again, feel free to ask me. It is that easy. And trust me, we'll just be adding one application and your entire backend will be good to go. Now we just have to work on getting it connected, which is also very simple. Because Firebase has such great libraries and so many developers working with it, even support is much easier. Right? Is anyone following along? I'm just waiting for my project to be made. Yay, it's done. Cool. So my project is ready. Now I'm going to be doing a very simple thing. All right. I'll be adding three things. All right. And this is the part where you're supposed to follow along a little bit. Simple. I have no doubt you're going to figure it out regardless of me helping you. Okay. But just try and follow along. That way it'll be easier for me to debug later in case you all run into trouble. Okay. Okay. Great. Let's go. Oh, lost the tablet. Okay. So we're going to be setting up three things. Authentication, Firestore, and real-time database, right? Authentication, Firestore database, real-time database. Let's start with authentication, all right? Get started. Folks, I do not have my eye on the chat. That's okay. We're going to be using a simulator B1D, so just come along. We'll use a simulator and we'll be making boilerplate code. So what's boilerplate code? It's basically code that once you understand that basic code, you can just pick it up and scale it however you want for projects, right? Whatever the idea be, right? Because you have a backend, you have a sensor sending, a controller sending data. You can get whatever sensor data you want, and you have an application that can read the data from the database. So once you have that entire boilerplate code set up, you can just scale it. You can make the UI however you want, and add layers to it, etc., etc. Right? So don't worry about it. Just jump in and follow along. So we're setting up Firebase right now. All right. There we go. So we clicked on get started, and now I'm going to add an email password method. Right? I'm going to add email password enable, save. All right. Then I'm going to go ahead and add, no, not add provider. I'm going to go into users and I'm going to add a user. So this email can be anything. This does not have to even be a real email, right? So what I usually do is I use it, and I have my own domain. So I use that. Works. And the password can be anything, right? So I don't know if you all can see it. Right. So I'm going to go for 1256 user, right? Copy it even and add user, right? So this, I'll change the password right away, don't worry, so it's not unsafe. And this is your UUID which you use later. If you all have done any application building before, you all know how it works, right? Folks, can you see my screen move, or is it getting frozen at any point? It's not getting frozen, right? When I'm doing all the steps. Aaron, that has happened so many times. I mean, it's not even funny anymore. Like, first time it was very funny. Second time it was like, oh, it happens. Third time I was like, why am I doing stuff that's getting me there? And yet here I am sharing my password for the user. So I didn't get hacked per se. I shared a collaborative file and someone just goes CTRL delete every time, and I still don't learn my lesson. I trust you hackers too much, okay? I'm telling you all. Okay, folks, ready? So I hope you all could see, you know what, I'm just going to do a quick thing for me, and there we go. Alright, so the screen might look a little shorter, but that way I can make sure that when I'm moving around on the screen, you all can see it. In case you all missed it, what we did was we went into authentication, we clicked on get started, then we went into sign in method, and we added a provider called email and password, and then we went into users and we created a user, okay? I have no clue what this is. I need to know more later. All right. Ready, folks? Cool. So next we're going to go ahead and what are we going to do? We're going to add the RTTB and yeah, you can add your email. Don't worry. That's not a problem. Okay? What we're going to do next is we're going to add our RTTB and Firestore. So let's go to Firestore next and set it up. Oh yeah, no, we do know that. Don't worry, the passwords gets changed immediately, so it's okay. It is very cool for us. Alright, Faraz, I hope you all are following along. And so we're gonna go to Cloud Firestore and click on create database. Let me know if you all want me to stop, if you all are following along. Okay. We're going to start it in test mode. Click next. I'm going to select something close by. I know there's a Mumbai. There we go. There's a Mumbai one that's closest to me. Y'all can choose whatever. I don't know if there are more centers in India. I think there was one in Delhi for something. Not sure what. Alright, so enable, right? I think for anyone joining in India, Mumbai might be the closest. Yes, ideally we should change the rules. But when we first connect the sensors to test the authentication, it's good to have the rules on the lowest security. Again, y'all are not doing it on stream, so I'm more confident about your projects not being hacked than mine. Hi Ahmed, welcome back to the stream. Ahmed is joining the stream after a really long time. Hi Ahmed. I'll try this wombo combo at some point. Alright, but let's stick to everyone getting set up. I don't want to confuse people just right now. Alright, folks, we have authentication set up, Firebase Firestore set up. Now we're going to set up the RTDB. Alright, so I'm going to go back to project overview, scroll, and at some point I'm going to find build features, and we're going to go to RTDB, create database. Again, I'm going to go for the closest one, Asia, and I'm going to start in. There we go. So once you're done with this, folks, there's just one step left and your entire thing is done. Alright, so once this is done, what I'll do is I'll go into my project settings. I'll come here, I'll click on web. Alright. If anyone's following along, let me know, I'll go slow. Or if you all want to catch up, let me know, I'll go slow. Alright. So, oh yeah, don't worry. This is part one, which was supposed to happen yesterday. I'll wrap this up in the next 15 minutes and then we'll start a new stream and everyone can join in from scratch. Alright, let's do my web app. What's the name of a web app? Let's just do the same name, GHW, live demo, launch. Alright, so I'm going to not set up Firebase hosting for now and I'm just going to register the app. Yes, let's Firebase indeed. Awesome. So remember this command. We'll be using it later when we create a React app. Alright. So let's get this going. This is what's important, right? So this configuration, if you want, copy it. Otherwise, it's very easily available. Do not hack my Firebase just yet. Alright. I'm already so anxious. I want to lead this project as soon as I showed my credentials. Why CRA? I don't get your question. Wombo combo. Oh, why create React app? I was like, why? Okay, now I understand. My bad indeed. So, no specific reason. I wanted to choose a tech stack that's easy for everyone to follow and something that if they learn, they can use it, right? So, yes, thank you so much, folks. You all can tell I'm a little slow with processing things today, but yeah. So I wanted to choose a tech stack that everyone can use at some point because, like, if I teach Android or Flutter or anything on those things, I'll have to learn it myself, right? I wanted to teach something that you all can actually use it and you can spin it up easily. So just basically what we're trying to do is we're trying to create an entire base project, right? So you have microcontroller sending data to your backend and you have some front end visualizing it. So we won't be working much on the UI, just on the sensor part, right? So you're getting sensor data onto your web page and you can process the data. That's all we're building. What we'll do in the last two sessions of the same track is we'll take that code and build projects with it. So you all have like a nice boilerplate code ready for your electronics projects and stuff like that. Yeah, I know, right? I'm so anxious right now because, like, I have paid. I've done it to myself and paid extra money because, like, I exposed the API key. So It's okay. I usually learn things the hard way, so that's okay. Okay, folks. So once you've done that and you have this going, you should be all sorted. Your Firebase is set up, right? You do not need to make any changes just yet. All right. So it is. So if you see over here, it's the no cost payment, and I'm not upgrading it either. So I think you need to upgrade it for a certain feature, or you want to scale it. If you want to scale it, then you upgrade it. So right now it's safe, but I still, yeah. So yeah, I usually delete my cards from cloud platforms these days. I'm like, not leaving it there. I remember when I was doing hackathons like really badly, my dad just walks in. Back then I didn't have my own cards, right? So like I was like, why did you spend 4K on like, Google Cloud? I'm like, what? What? And I was like, yeah, that was bad. He was really chill about it, which was very sweet. But yeah. Awesome work. So your Firebase is set up. Yay. Alright, quickly tell me, do we want to start setting up Create React app? So we'll do that, or we can start with the basic Arduino commands, understand basic Arduino code and the structure, and I'll just stop the stream and restart immediately the next stream, right? Because we'll have a little division of content that way. Sure. So basically, in Create React app, what we're going to do is we're going to npm install the Create React app, of course. Then we're going to use the command, and what Create React app does is that's the thing. Both of them are going to make equal sense because there's steps, right? You have why I set up Firebase first. When I realized that was now you have the center point that connects both of them. Now you just need to take both the components and get them connected to your main, connecting point. So yeah, so Create React app, we'll do that. Then I'll just take you through the basic code of how the structure of Create React app is, and we will add code to connect to Firebase. So first we'll run the npm Firebase command that we just saw, and once we connect to Firebase, we'll read and write data. We'll probably just do one of them. I usually use code like I've also learned through tutorials, right? So I usually use some nice tutorials. I'll send you the links if it doesn't work for you right now. That is a good point, V1D, but I'm paranoid nonetheless. So I'm gonna, because see, the thing is, this is not my area of expertise, right? So it's like, how you all are very scared of, if you ever played with LEDs. I'm like, LEDs, nothing will happen. I'm used to it. I play around with it. This is fairly new zone for me, and I'm not dabbled much, so safety never hurts, right? All right, folks, let's move on. Since the Firebase is ready and y'all aren't selecting, I'm gonna go ahead and choose the Wokwi thing because the other part, Create React app, will require a certain amount of installations, right? I feel you. If you all have ever heard a capacitor go off, it sounds like a gunshot. It's very cool. Do not try it. But yeah, let's go to Wokwi. And what I'll do is parallelly, I'll give you instructions for installations. So when I close this stream in the next 15 minutes and restart the stream again, in that you can actually start the installations in the process. All right, because I'll be starting like from scratch, basically like it's a new stream. So all right, awesome. So let's go to Wokwi. I'll be sending you the link. Let me send you the link. Wokwi.com. So in case you all have joined the streams earlier, we have used Wokwi before. Wokwi is a similar simulator platform, but it's slightly more sophisticated than Tinkercad and less sophisticated in other ways from Tinkercad. But it can run much more complex code. So not Wokwi. Wokwi. This is a very cool suggestion, V1D. Thank you so much. I will definitely try this. Or you know what? If you want in the next stream, you want to hop onto the stream and show us how to do it, I'm happy to let you show us how to do it. Oh, this sounds like a fun experience. I would love to know more about this story here. Okay. So let's go back here. Let's refresh. This is my project. Cool. So everyone's going to work me till then. What I'm going to do is I'm going to quickly write down some steps in the chat and post it together so that you all can just go through it. Alright, so if you all like don't have, let's say, Node.js and stuff like that, you all can quickly install it. So I would suggest instead of installing Node.js, install NVM, that is Node Version Manager, uh, for multiple reasons. Because you all are also part of the FPHs. I know you all are active parts of FPHs. Sneak has had problems recently, right? So we have figured out a way to solve it through NVM, which also most of the hackers suggested before, and I tried it. So it works great. So I would suggest trying NVM. So in case you all don't have, go ahead and install NVM. I've sent you the link to NVM. Then what you need to do is you want to install Create React App. So the command for that is npm install Create React App. That is it. Those are the only two things that you all need to do. Once you're sure the npm create React App command runs, we'll be good to go. Alright, so this you can keep doing on the side. Until then, what I'm going to do is I'm going to quickly open wokwi.com myself. So let's go here and pick wokwi.com. Wrong link. Wokwi.com. I'll probably sign in as well. I don't know if I last time signed in or not. I'm going to sign in. Google. Alright, there we go. Alright, I'm going to go ahead and create. Oh, we did do a couple of projects. So this was me trying out Firebase ThinkView. This works, by the way, now, so I'm very happy. I'm going to go on a new project and I'm going to click on ESP32. Alright. And I've paused the other one so that in case this one does not run from scratch, you all know how the running version works. Awesome! Thank you so much for volunteering. That is awesome. Thank you so much. Uh, I did not. I did not run into any permission issues. So I'm hoping no, you shouldn't run into. Did you get any issues? Again, not the expert here, but I'm sure people in the chat will be able to help you out pretty well. Ah, is that so? No, I actually had a very smooth experience, but then I've never really shut down my computer since the first time I did it, so I could be wrong. Yep, it is mandatory. No, you need to authorize the installation, that I agree, but after that, you all don't have any problems, right? Like, I didn't have any problems, but yeah, if you want, you're happy, you're welcome to hop on the stream and share your screen, and we'll debug together as usual, right? So, all right, Alvin. So we'll keep you in mind, and if you want to hop on this stream later, the next part, and walk through your problem, we'll do it. You'll be helping a lot of other people who are facing the problem too. So think about it. Awesome, folks. Let's go back to our controller. All right, I'm trying to make this a little bigger so that you can see it. Okay, this should be better. And okay, never mind. Cool. This is slightly better in resolution, so this should work perfect. So I'm gonna actually go ahead and move this here. Perfect. See. No, Alright, so this is an ESP32. How is it different from Arduino? Okay, so usually I cover these things in a lot more detail, but just get the gist of it, you're good to go, because that's not the main concern of ours right now, right? So ESP32 is basically another architecture, right? So an Arduino is an AVR architecture, right? ESP32 is extensor architecture. Similarly, you must have heard about the ARM architecture, right? It's fairly common these days to hear about ARM, or even more, trendy right now is RISC-V, right? So, or risk-free, however you call it, right? So basically, architectures are nothing but structure of your components inside it, right? So your logic gates, your serial buses. What do you mean by serial buses? Basically, how you're transferring data, right? How are you validating the data? So one is, of course, you connect the wires, you short the machines, and you send data, which will send the data, and you might receive it, you might not receive it, you might receive some part of it, you do not know. So then you have different protocols like SPI and I2C that help you, connect and verify data, right? Ah, I see a command. Nice, it's working for Alvin. Awesome. So, right, so there are multiple ways to go about it when it comes to architecture. And architecture is basically about how it processes commands internally in the registers. So what Arduino IDE does for you, it makes your life very simple by kind of, aggregating all of it and abstracting it basically to a point where you write a single piece of code which can actually be, run on different devices, right? So what I've done here is I've created a new project on Wokovi with an ESP32. So that is it, right? So if I run this command right now, like run this code right now, it's printing hello ESP32. Simple enough, right? Now what we're going to do next is basically we're going to write some basic codes and add some basic components to kind of just get a hang of code. It's like when you first time learn a language, you know the basics, right? You know the logic, you know the functions and everything. It's the getting hang of the syntax that matters. Right? So we'll just do a little bit of it and you all should be good to go. As usual, I'm going to take an LED, right? So let's take an LED. I know I can change the color somehow. I like yellow LEDs. I'm going to go ahead, zoom in a little and connect it, right? So I'm going to connect it. This is anode, cathode, anode is positive, and it goes to 18. This one can go to ground. Remember, negative always goes to ground. Then what I'm going to do is I'm going to flip it so that it looks good. Alright, there we go. I have my LED there. What I'm going to do next is I'm going to open the ESP32 pin out to see what pin am I addressing, because in ESP32 the pin you address versus the pin you write is slightly different, right? So I'm going to go here. See, because the GPIO is different, right? So I did D18, right? I hope the model is same. Yes, 32, D23. So GPIO 23, so GPIO 18 should ideally be correct. Yep, 18 is correct. So I'll just go and write 18 on the pen. So I'm going to go here and write a digital write. See, we have a very nice code completion here as well. Okay. And yes, it's the void function is what runs forever. I'm just going to explain the structure as well, right? So then I'm going to go 18. I'm going to write a hi, right? There we go. Now I'm going to add a couple of more things, right? For example, how does the controller know that whether it's supposed to read the pin or write to the pin? There is something called pin mode. Now, I shouldn't have to select the pin mode every time I'm writing, right? I can't say, okay, now I'm writing to this pin, right? Or I can, of course, if I'm switching it. But if I'm not switching it, it doesn't make sense that I'm every time asking the, controller to make sure that it's a writing pin. So what I'm going to do is I'm going to go here and go 18, and I'm going to do output, right? So pin mode 18 output. There we go. So then we have digital write, which is doing high. Now, okay, what's happening here is the setup runs once, right? And the loop runs forever. So now let's say you have a very complicated code, right? Alvin, this is for you, right? If I have a very complicated code where I'm calling interrupts and I'm calling timer interrupts and I'm, scheduling stuff, all of that will come inside loop, right? So it's the same thing that's running forever. Exactly, right? So you get the point. Any controller will have this kind of code, unlike your GPOS. Make sense? RTOS time, what do you mean? What's RTOS time? As in the frequency of this? I think it's 170 kilohertz. I know it's 170 kilohertz for STM32. I do not remember exactly for ESP32, but let's see if I can look for it. You are. Mm, ESP32 void loop. Let's see. 16 megahertz, which does not sound right. So 8 to 10 microseconds. So if you do 1 by 10 microseconds, you'll get what? Around 1000. So around 1 kilohertz. 1 kilohertz is your frequency basically. Actually 10 kilohertz. 10 microseconds, right? So this is an RTOS. This is an RTOS, Alvin. Arduino IDE is actually an RTOS. You're basically scheduling stuff, right? Every time you put a delay, you're basically writing a real-time operating system. Make sense? Alright, let's continue. Alright, so I've put a digital write. Hi, let's run this code and see what happens. And it's glowing. So that works, right? Now let's try and make it blink, right? So I know that there's no PWM, there's no DAC to even run PWM. So I'll have to do it manually. So let's do this. Right, I'm going to copy this entire thing. See. Now, this is only true for simulation, okay? This delay 10 does not speed up your actual code in real time. Yes, it is. You're having interrupts. You're basically writing an RTOS. It's just much easier and very much abstracted. Otherwise, it's basically the same thing. So if you go and look at an actual RTOS also, you're doing the same thing. You have a device tree structure and all of that Arduino is taking care of it for you at the back end. That's the only difference, right? All right, folks, right? So I'm going to do this and then I'm going to do what we were trying to do earlier, right? So we have a 10 car delay. So I'm going to make it 7 and 3. And let's see what happens, right? The brightness should ideally reduce. Let's see what happens when I do 5. I need to keep it closed for longer. So I'm going to make this 4 and this 8. Or rather, 8. Yeah. Let's see what happens. So it's basically the same thing, right? You're calling different things. The essential code blocks remain the same. Yes, you can do a lot more handling with an RTOS, which is called an RTOS. But in Arduino, you're doing the same thing. But because it's so abstracted, it's much easier. But it's also, you have a lot less control. So when you do a command, there are a lot of, prerequisites that it's already solving. Make sense? Right, so this is supposed to start glowing less. Now, I do not have a way of making sure it is. Regardless, if you run this code, you should get a little hang of what's happening. So this serial.begin, do you see this? This is your baud rate. Now, I do not want to explain in too much depth what's baud rate, but if you get the general idea, right? It is less bright. I don't know. I can't tell the difference really. I hope it's less bright, but that's how basically you're going to make it work, right? So let's just increase this thing and check. I don't know. I'll make this much lesser and let's see if it makes a difference. It should be significantly different. It does look lesser, I agree this time, but I can't be too sure. I'll have to probably make it like even lesser. So maybe like delay milli dot delay. I don't remember the command, and I'm pretty sure I can't put like a decimal number. Does anyone remember the millisecond command? Let me check on Arduino quickly. I don't remember. It's okay. The basic idea remains the same, and you all understand it. That's what matters. Brendan. Sure, I'll answer all your questions in around 10 minutes when I start the next stream. Until then, just hang in, alright? Awesome. So let's go. So once you are here, you should have a good idea of what's happening, right? Uh, Let me know if you all have any questions. If anyone's following along and is stuck anywhere, your LED should be glowing. What we can also do is we can kind of write a mm, repeating loop. So let's do the same thing. So let's do here C V and let's run this. Oh, you know what's happening? You know what I realized? Because I'm not turning it off at any given point. So it won't happen, right? So I need to turn it off for a certain amount of time. That is what is. Sorry, folks. So you need to turn it on and off, right? And I'm not turning it off at any given point. So obviously, it won't work. So we're not really turning it off. So there we go. Stop. So this is visibly less bright. I hope. I'm not sure. So let's do this. And I'm going to do the same thing again. To the simulation. Yes, trust me, I know. I know you can't. That's the thing I said. It is more sophisticated and less sophisticated than Tinkercad in some ways and the rest. Uh, Digital multimeter. So no, I can't find it. I think there might be one. No digital multimeters here. Alright, folks. So this is basically your code. So if you all are comfortable writing itna and you understand, the syntax, you all are good. Alright. So I'm gonna bring this right here and stop sharing. Alright. So I'm gonna quickly go. We'll take another 5-minute breather because it's been another 40 minutes. And we'll come back and start with the Create React app and connect it to Firebase. Or we'll continue the Arduino code and write our Firebase code there. I'll take you through some basics of libraries and things like that. We'll very quickly install Node.js and stuff, and we'll come back and I'll create React app and push data from the Create React app. Right? We'll create a quick form and we'll push data. It's very simple, and no brainer, right? So you all are good to go either way. And I'm going to quickly close this stream, and I'll be back in 5 minutes. That's me soon.